In section 6.8, you're going to be working with transforming polynomial functions, and we're going to add to this table here. It says transformations of f of x, and we're going to use the cubic function, or the table involves the cubic function. So you've worked with transformations in several different sections. This notation is going to be just a little bit different, but it's really not hard. The notation we're going to use is f of x. So if we want to perform a vertical transformation, vertical affects the whole function. So we're just going to, instead of writing the whole function, the x cubed, we'll just say the function f of x, because sometimes the functions will be quite long. So if we want to move the function up, we're just going to add a number to the function. So example here, if we add 3, that means we're moving up through the function up 3 units. If we subtract 4, we're moving the function down 4 units. If we want to do horizontal transformations, remember these are the ones you have to watch out for, so if you want to put a little star next to that one, horizontal transformation happens inside the parentheses with the x, and it's opposite of what you think. So if you want to move 2 units to the right, you're actually going to subtract inside the parentheses. If you want to move 1 unit left, you're going to add inside the parentheses. Now back to vertical. Vertical, basically what you see is what you get. So if you want to stretch by a factor of 6, you're going to multiply by 6 to the whole entire function. If you want to compress here by a factor of 1/2, you just multiply the entire function, which just is x cubed, by the number 1/2, which is different than what you do with a horizontal stretch or compression. With a horizontal stretch or compression, you take the number and you take the reciprocal of it. So when we look over here, when we're seeing 1/5 times x, that's actually a stretch by a factor of 5, because we first have to take the reciprocal of this number, and then if it's greater than 1, it's a stretch. If the number is 3 inside here, we have to take the reciprocal, which turns into 1/3, and then we decide if it's a stretch or compression. So always take the reciprocal first and then decide if you have a stretch or compression. When we're reflecting, we take the opposite. If we want to reflect over the x-axis, we take the opposite of y, which represents the entire function. If we want to reflect across the y-axis, you take the opposite of x. And remember, you can see that with a point if you forget what you're changing when you're reflecting across what axis. Let's just put the point, we'll do 2, 1. And if we flip that over the x-axis, the x stays the same, and it goes to 2, -1. So the y goes to the opposite. So whatever axis, if you're reflecting across the x, you take the opposite of y. If you're reflecting across the y, you take the opposite of x. All right. Earlier this year, you performed transformation on linear and quadratic functions. In section 6.8, you will perform transformations on a variety of types of polynomials. So remember, horizontal transformation takes place inside the parentheses with the x. Vertical transformation takes place outside the parentheses away from the x. Again, when you reflect over the x-axis, you take the opposite of the entire side, which means y. And when you reflect over the y-axis, you take the opposite of the x's only. Okay, so let's do some transformations. I'm going to have you change that polynomial function to read x cubed minus 6 instead of the function that you have there. Okay, so when we have, what this means is you're going to take this function, so the whole thing, and then we're going to subtract 4 and decide what the transformation is. Well, when we subtract 4, all we have to do is just, because it's the entire function, which is y, we're just going to subtract 4. Here's our function, subtracting 4 just gives us -10. And this represents a vertical, because it's not inside with the x, transformation, because it's a subtraction, and that just tells us to go down 4 units. The next one that we have here is inside with the x. So that is a horizontal transformation. So we're doing exactly what they're saying. They're saying go to where the x is, and we're going to change the x to make it x minus 6. We're going to cube that, and then the minus 6 is the rest from this function right here. So we're going to add it on there. Now, I'm not going to have you multiply that out or cube the whole thing. does, because that would be x minus 6 times x minus 6 times x minus 6. Sometimes in your book, if you're doing some problems, they'll multiply it out. Sometimes they'll leave it like this. So we're just going to leave it like this so we can see it better. And that transformation is inside, so it's horizontal, but you're not moving to the left. You're doing a horizontal transformation to the right 6 units. Next one, we have, you can see that we're multiplying the entire function by 2. So again, you just replace this f of x with what you were given, x cubed minus 6. And here I am going to have you simplify because that's pretty easy to do. We're just going to distribute right through the parentheses. And because it's on the outside, it's going to be vertical. Because we're multiplying, it's going to be a stretch by a factor of 2. Number 4. You are taking the opposite of the entire function. So again, this just means whatever function you were given. Here we were given x cubed minus 6, so we're just going to put a negative sign on the outside there. And this one we can also simplify. And that will give us, when we distribute that negative, we get a negative x cubed plus 6. Because we're taking the opposite of y, it's a reflection over the x-axis. Okay, question number 5. We are taking the opposite of the x, which means we're reflecting across the y-axis, and we just go inside here and take the opposite of x, and then we're going to cube that, so it's a negative times a negative times a negative, which remains a negative, and this doesn't change because it's horizontal. That's a reflection over the y-axis. The next one we have is g of x equals 2/3 x. So this is saying take that function f of x, multiply it by 2/3. So we're going to put it on the outside there, and here again we can distribute. So we're going to do that, and that will give us 2/3 x cubed. And if we just multiply, this is like 6 over 1. So that would give us 12 divided by 3, which is 4. And that is going to be vertical because it's outside. And it's going to be a stretch because we're it's going to be a compression because it's in between 0 and 1. So it's a vertical compression by a factor of 2/3. Number 7, now we're doing horizontal. Okay, so what it's asking us to do is go inside with the x, multiply it by 2/3. So when we do that, we still have to cube it. So 2 cubed is not 6, it's 8 because it's 2 times 2 times 2. And then 3 cubed is not 9, it is 27. So that is going to give us 8 over 27 x cubed minus 6. And now be careful here. We multiplied by 2/3. We have to figure out if it's a stretch or compression. First we have to take the reciprocal. So it's actually going to be a horizontal stretch by a factor of 3/2. Okay, on the other side we have just a couple more here to do. And we are going to compress vertically by a factor of 1/3 and shift 2 units to the right. Now, usually it's better to do these one at a time. So we're going to first compress it vertically. So that means we're going to multiply the entire side by 1/3. And when we do that, we can distribute that 1/3 through. 1/3 times 6 is 2, and if we multiply through here by 1/3, we'll get a minus 1. Now, after that, now we're going to go ahead and shift it 2 units to the right, which means it's just going to affect the x. So inside the parentheses, we're moving to the right. That means we're going to subtract because it's horizontal. So we're going to do change just the x here. Moving to the right, we're going to subtract 2. That's cubed, and then we don't have to forget, or we want to remember that minus 1. And again, I'm not going to have you cube that out. All right, number 9, we have reflect across the y-axis and shift 2 units down. So again, do one transformation at a time. We want to reflect across the y-axis, which means we're going to take the opposite of the x. So when we take the opposite of the x, that still gets cubed. And then we have the minus 3 from the, oops, you can't see the original function here. Let me slide that down, from the original function. So if we cube that, we're still going to get a negative x, so it's going to be negative 6x cubed minus 3. Then we want to shift it 2 units down. So while 2 units down would be the whole function, we're just going to, since it's vertical, if it says to go down 2, we're going to subtract 2. And then we can just simplify that function. Okay, a couple things I want you to add in here. I want to give you a function that has a few more variables in it. So go ahead and copy this function. F of x equals x cubed plus 5x squared minus 8x plus 1. And we want to reflect it over the x and the y axis. So I want to show you the difference between reflecting over the x and reflecting over the y-axis when you have several variables. If I want to reflect across the x-axis, that means I have to take the opposite of y, which is the entire function. So the negative sign goes on the outside of the parentheses, and I take the excuse me, I take the opposite of every term. So I took the opposite of this, opposite of this, opposite of this, opposite of that. Now, if I reflect across the x-axis, you need to go inside each, or put parentheses around each x and take the opposite of it. So this is what it's going to look like. Original polynomial is here. Put parentheses around this one, take the opposite. Parentheses around this one, take the opposite. Parentheses around this one, take the opposite. Nothing happens to 1 because it does not have the variable x with it. Now you're going to simplify, so it's negative x cubed. Negative x squared is just going to give us a positive x squared because it's a negative times a negative. And here we have a positive 8x and then just a plus 1. Okay, you have something to try on your own.